Hi, and welcome back to the Reconciliation Project podcast, where we're formed by faith and informed by science. I'm Sam.
And I'm Hunter.
And today we're going to be covering the topic of embryology and how it relates to evolution. So embryology is a field of science that specifically covers development, particularly embryos. Hunter, you've studied a good bit about this and taken quite a few classes on embryology. Would you like to go ahead and jump in and start this off for us?
Yeah, so embryology as a subject as a whole really focuses on, as you said, embryonic development across a wide variety of different organisms. Specifically for humans, which is more what I've taken, it's the study of the first 8 weeks of development when the developing child is still considered an embryo. Once they hit week 9, up until birth, they're considered a fetus. But in those first 8 weeks, it's considered an embryo, and that's what embryology really focuses on. And for evolution, on the evolution side of things, embryology has played a pretty big role in the development of the theory of evolution to what we have today. Originally, when embryology was, emerging as a field, it was thought that embryos, as they develop, they would display their evolutionary history. So what I mean by evolutionary history is we know that in evolution, it's said that we descended from common ancestors. And the idea in embryology is that as an organism develops, they would go through phases that represented the adult forms of their ancestors.
So, for example, humans potentially having gills in the womb?
Yes. So gill slits are a factor into this. Humans do have gill slits when they're in embryonic development. Those gill slits actually become the parts of the inner ear. But the idea was that those gill slits are there because ancestors to humans are aquatic or marine animals or some sort of fish. And the idea is that for this evolutionary history thing is that the embryo would go through a phase representing fish, then reptiles, then early mammals, and then finally resembling more of a human once you get to that late stages of development. And this is what's called the recapitulation theory. And a big name in that was Ernst Haeckel. And he is known for his embryo drawings that he did many years ago. And in these drawings, he kind of illustrated this recapitulation theory of how the embryo went through those phases, those stages. And when you look at his drawings, you can really look at a lot of science textbooks will have some sort of image of embryos in their various stages of development. And you can see they do look very similar across different organisms. Typically, you see comparisons between a bird, or specifically a chicken, humans, fish, turtles. Sometimes you get a lizard or salamander in there. It just depends on the specific drawings. But all of those images are derived from what Haeckel did in the past. And like I said, his drawings were an illustration of this recapitulation idea and showed, like I said, how they look similar and how they went through those evolutionary history phases.
But wasn't there an issue with Haeckel's drawings? Didn't that get somewhat disproven?
Pretty much, yeah. They're pretty much right when he put his drawings out, once he published them, for lack of a better term, he immediately received some backlash from embryologists at the time who said this doesn't make sense and this might just not work the way you presented it. And what we found over time was that this recapitulation idea was actually disproven by many embryologists. Most notably, Michael Richardson compared Haeckel's drawings with real images of embryos at the same stage of development depicted at the drawings. And what we see in that, or what he saw, was the embryos were not as similar to each other as Haeckel showed. And so this got us thinking, okay, well, Haeckel clearly altered or exaggerated his drawings in some way. And later on, Stephen Jay Gould showed how Haeckel's drawings were exaggerated and altered, and he showed that evolutionary changes cannot be tacked on to the end of development. So what I mean by that is the embryo does not go through and displaying their evolutionary history. That's just not what happened. And part of that, like I said, is because it doesn't make sense evolutionarily or biologically for a stage or a phase to get tacked on to development. So like I said, with the fish, it doesn't make sense for the reptile phase to get tacked on to the fish phase of development, and then the early mammal phase get tacked onto that. That's just not how that works. And these embryologists came and said, hey, this recapitulation theory does not work. And ultimately, Haeckel's drawings, the conclusion is that they were largely exaggerated and that the ideas behind them weren't necessarily bad, but the drawings weren't great either. And as a result, we had to kind of change how we viewed embryology from the evolutionary side of things. And what we do see in terms of similarities and evidence for evolution is the kinds that are more similar genetically, like we talked about last episode, look similar in early development. So humans and chimpanzee look very similar in development because they're genetically similar. And we see similar developmental processes, similar gene regulatory networks, and similar signaling pathways. Human developmental genetics is studied largely in fruit flies, which have very similar genes and gene regulatory networks involved in development. So fruit flies and humans have very similar processes in development. And because we've been able to study fruit flies so well, it's given us a much greater understanding of human development and the genes and the signals involved with the proper development and differentiation of those early stem cells. It's been really crucial for our knowledge overall of human development, because we can't do much research on human embryos because ethics largely prohibit it, but we can on model organisms that are similar genetically and developmentally like fruit fly. And these similarities between these completely different organisms, I mean, I think we can agree humans and fruit flies look nothing alike, but they share similar developmental processes. And from this fact, the idea for evolution is, oh, there must be a common ancestor here because these processes are so similar, yet they're so different in their adult form.
So how does evolution and embryology really fit together? You mentioned earlier that, especially with Haeckel, there's a big disconnect there, and that doesn't entirely jive in the way that Haeckel talked about it. But then you mentioned the fruit flies and how we are similar developmentally to fruit flies and how we develop. So what's really the sweet spot in how embryology and evolution kind of come together?
That's a good question. I think the main idea is because they share these similar developmental processes, similar genes, similar networks, regulation networks, similar signaling or signaling patterns or signaling cascades, depending on how you look at it. The idea is that evolution, or as these organisms arose through evolution, those developmental processes remain largely unaltered because, I guess for lack of a better term, because it works. We see it works for all different sorts of organisms. And as evolution, and this is what evolution proponents would say, this is not me saying this is what the science would say. As evolution worked and gave rise to new organisms, the development remained largely the same. While everything else was changing, the developmental processes themselves didn't really need to change, so they did.
So if it ain't broke, don't fix it type thing.
Yeah, pretty much. And ultimately, how you view embryology and evolution and all this really depends on your worldview, which we've talked about several times in this podcast. Your worldview is how you view the world. For evolution, through the lens of evolution, these similarities in developmental processes and the genetic side of it and the signaling and all those things, those similarities are the result of common descent. So like I said, we see these completely or seemingly unrelated organisms with a very similar or identical developmental process, and that, in the eyes of most scientists, is evidence of common descent. If we share these developmental processes, then we have to all be related somehow. So, like I said, that's the evolutionary view of it. On the creation side of things, one can argue that these similarities are the result of a common creator. I mentioned as we were closing out last episode that these similarities genetically could be the result of a common creator using the same themes across all of life. And I mentioned how authors, when they write a series of or a set of books, the plots of the books, all of the characters can be completely different, but you can identify the author based on their themes, their writing style, the verbiage they use, the language they use, and you can see those similarities across completely different books because they're by the same author. Same thing with artwork. You see those same themes and patterns, and I guess the right word is motif in art. You see that across completely different painting or pieces of art because they came from the same artist. And the idea in creation is all of life is going to share similarities because they're made by one creator, one designer. And as a result of that, we should expect to see similarities. So ultimately, what I'm saying is, like I said, it comes down to your worldview. We have the same piece of evidence here. We see these similarities. And you can go one of two ways with it. And it really depends on what you think ultimately. I saw some evolution proponents say, if it ain't broke, don't fix it, as you mentioned, suggesting that developmental processes remain similar across many forms of life because it works and there's no need, quote unquote, to change it through evolution. Personally, I would agree with this statement overall with if it ain't broke, don't fix it. But like I said, I reached a different conclusion. And I think it really captures why this debate exists in the first place. If I think there's a common creator who is God, I would say that he would use the same processes in different forms of life if it works. And he knows what works. So there's really no need for him to put something different in every organism. I saw some comments from evolution proponents that said, why wouldn't a designer use different things for each organism? And in some cases, you have to, but for things like development, if there's no need for something different, then why would you put something different? And I'm not trying to say, oh, God made everything look evolved. I'm not trying to say that. What I am saying is he used a process that works across many forms of life because it worked for all of them. And like I said, I can come to that conclusion based on these similarities, but someone else can come to the conclusion that everything's evolved from a common ancestor based on those same similarities. So ultimately, it really depends on what we've talked about before, where everything came from. Is there a God? And ultimately, is there a creator authority? So at the root of this, it's really not, in my opinion, a debate between faith and science. It's a debate between two competing worldviews and overall two ideas of, is there something supernatural? If you don't believe there's anything supernatural, you're going to come to a completely different conclusion than someone who believes there is. Like, I'll give an example. Several years back, I don't remember where it was, but a monolith appeared randomly in the desert somewhere. For those who believe in aliens, many of them I saw argue aliens left it. Other people who say, no, there's no extraterrestrial life will say someone just put it there as a prank or there's some other explanation for it. And the reason I'm bringing this up is it's the same monolith, two completely different explanations based on two completely different views of whether or not aliens exist. And I think the same concept can be applied here. So like I said, at the root of it, it's, is there God as a creator or is there? And I think as Christians and as a church, we have to be aware of that fact, that we're not debating somebody in the sense of faith versus science. We're having a conversation with somebody who doesn't share the same beliefs about God as we do. And I think a lot of times in these debates, we miss that. And I think that's a really big way that Christianity and Christians and creationists fail when trying to reach people who have these different views scientifically, because like I said, it's not a difference of evidence or anything like that. It's a difference of conclusion, which is based on a difference of worldview.
Absolutely, yeah. And I think that's really important that we all tie this back to our God, our creator. As we continue in our series of evolution and other topics, we are actually going to be talking about homology and how homology ties into evolution next time. Homology, just as a preview, is kind of talking about the similarity between characteristics. So we'll be talking about the similarities that we see between different organisms, kind of how you were talking about how a creator might use similar aspects across different areas of creation. And we'll be covering that in how evolutionists tie that into their theory. So we hope you'll join us next time as we cover homology and evolution.